Professor, it's under chapter 2.
Yep, it's under chapter 2. So lecture worksheets, chapter 2, is right under all the other worksheets we've done for chapter 2.
Professor?
Yep.
Do you recommend us printing it out and sending you a picture and posting it?
You're talking.
Or you just want us to like download the file and then write over it and just submit it as a PDF?
Oh, that would be nice if you're able to do that. I'm not having you submit this density worksheet. Are you talking about the lab?
Yeah, I meant the lab.
Yeah, yep. That would be great if you could do that for the lab. If you can't, no big deal, print it out like you said. But before we get to that, I want to go over this and then I'll give you guys more detailed directions of how I want you to submit the lab.
Okay.
All right. All right, guys. So we're doing density. And remember, density, the equation for density, all density is a substance's mass to volume ratio. When we talk about density, we're saying density is the mass to volume ratio. The SI units for density is going to be the SI unit for mass, which is a kilogram. And the SI unit for volume is meters cubed. Remember, any unit cubed or any unit of length that is cubed is going to be volume. But most generally, we're going to be calculating density in units of grams per milliliter, which is the same thing as saying grams per centimeter cubed. All right, so we're just calculating the mass in grams, the volume in milliliters, and calculating the density from that. If we are saying density equals mass over volume, I will give you guys, go ahead and rearrange this equation. So if we want to solve for the volume, what would we say, guys? How would we rearrange this equation? Volume equals what?
Mass over density.
Equals mass over density. I'm just switching places with the V and the D. And then if we wanted to solve for mass, we'd say mass equals
volume over density.
Volume times.
All right, so look, if we're looking for M, close, but we got to do the opposite of what's happening to M. M is being divided, so we're going to have to multiply the density
by volume
times volume.
Yes.
Okay. So you are expected to be able to know how to rearrange this equation because the questions might ask you for the volume, the mass, or the density. If you're having trouble, just let me know and I can quickly show you how to do it. But in general, let's pull up this density worksheet and let's go over these first couple of questions together. So the first question says, can you guys see my density worksheet okay, or at least see the one in front of you okay? And let's pull out our calculators. So the first question says, a student measures the mass of an 8 centimeter cube block of brown sugar to be 12.9 grams. What is the density of the brown sugar?
1.61.
So in this case, we are given a block of brown sugar, just like
12.9.
Right. Okay. So we're given a block of brown sugar. So let's say it looks like that. We're saying the volume of this block is 8 centimeters cubed. And the mass of it is
12.9.
right. So if we put this in our calculator, let's set it up. My pencil ran out of lead. We're going to say density equals M over V. It's as simple as Johannes is saying, 12.9 grams divided by 8 centimeters cubed. The only thing that we have to pay attention to now is our significant figures. So remember when we're doing division or multiplication, the rule says what, guys, for sig figs?
The least amount or something?
Yep, the least amount of significant figures. So the least amount of sig figs in this case is how many, guys?
2.
One.
One, right?
1. Yep.
1.
12.9 has 3 and 8 has 1. So the least amount of sig figs is 1 sig fig. If we put this in our calculator, we're going to say 12.9 divided by 8. We get 1.6 as our answer, but what's 1.6 rounded to 1 sig fig?
2.
2.
All right, great. We all see that it's 2. You see, guys, we're gonna do this enough to where it's gonna be easy. So 2 grams per centimeters cubed. That's gonna be the density of this brown sugar. Let's go to the next one. A chef fills a 50 milliliter container with 43.5 grams of cooking oil. What is the density of the oil? So think about the cooking oil. If you have olive oil in your cabinets or vegetable oil, we're just trying to figure out what the density of this oil is. If we take the mass of it, once again, density equals mass divided by volume. So we're gonna say the mass is 43.5 grams. The volume is 50 milliliters. All right, so tell me how many
Point
stick
18.
figs I should have in my answer.
2.
No,
many stick figs?
0.87.
How many stick figs does the top number have?
3.
3,
How many stick figs in 50?
2.
1.
2.
One.
1.
Oh, 1.
1.
2.
Oh,
Nope, it's 1, guys. Remember,
1. Oh,
there's no decimal. It's that 0 doesn't count. We gotta have a decimal for that 0 to count. So just a reminder of stick fig rules: 0s at the beginning of a number don't count. 0s at the end of a number with no decimal don't count either. So 3 stick figs divided by 1 stick fig. Our answer should have 1 stick fig. What do you guys say?
0.9 grams per milliliter.
Wouldn't it be 1?
1.
All right, so we know it's 1 stick fig. So we say, okay, this is my first stick fig. That's the only one I need. I need to look to the right and round it up or not. In this case, I'm gonna round it up. We're gonna say 0.9 grams per milliliter. Do we see that?
I thought it was 1.
So I get that you're trying to round it up to 1, but you know, if you're rounding 8, the next number is 9, not 10. Do you get what I'm saying?
Oh, I was rounding the 0.
Yep, but remember the 0 is not significant. We're gonna go to the first
Right.
specific number we see and then round it.
Okay.
So
I
when we're
see.
counting our stick figs or when we're rounding our stick figs, we have to go to the first significant number. So we skip the 0 because it's not significant. We go to the 8 and then we round the 8.
I have a
So thanks for
question.
pointing that out. Yep, go ahead, Kanza.
So for number 1, so the answer was 1.6. We rounded it to 2 because we knew that it needed to be 1 stick fig, right? That's the only reason why?
Yep,
Okay.
yep. Same thing with number 2. We needed 1 stick fig, so we rounded to 0.9.
Okay, thank you.
All right, number 3 says now we're gonna calculate the mass. So if we're gonna calculate the mass of the liquid, we see, okay, we know that our mass equals density times volume. So that's what I'm doing here. Mass equals density times volume. Now, in this case, we just got, which one's my density, guys? Which number?
0.5.
2.5.
All right, 2.5 grams per milliliter. And then we're gonna say times the volume, which is 15 milliliters. So in that case, if we multiply them together, the milliliters will cancel out and we'll be left with units of grams. How many stick figs in 2.5?
2.
2.
How many in 15?
2.
2.
How many should my answer have?
2.
2.
All right, so let's see,
38.
2.5 times 15. Round this, we see it's 38.
Yes.
1, 2,
38, yeah.
look to the right, round up to 38. So this is 38
Gram.
grams.
Professor, can you go over that problem a little bit slower?
Say it again.
Can you go over that problem a little bit slower, please?
Yep, so we see that we have mass equals density times volume, because that's what we're looking for. And we're saying the density is 2.5, so I put 2.5 in for D. The volume is 15, I put that in for V. I multiply these numbers together. This has 2 stick figs, this has 2 stick figs. My answer should have 2 stick figs.
And you said we no longer put the ml at the end because those canceled out.
Right, because ml stands for volume. Remember, milliliters is a unit of volume, and we're calculating a unit of mass. So the unit for mass is grams.
Oh, okay.
All right, so that's why we have to go over the units so we are clear on what each unit means. When we talk about volume, we're talking about liters, we're talking about centimeters cubed, we're talking about milliliters, like gallons. Think about liquids. For instance, this bottle of water that I have right here in front of me. It gives you the volume of the bottle of water. Can you guys see this?
Yeah.
Is it right here, 500 milliliters or 0.9 fluid ounces? These are all volumes. So we got to recognize what the units mean and know that what we're talking about, what measurement we're talking about.
Okay.
Okay. All right, let's keep going. Let's do number 4. Number 4 says, let's calculate the volume of a liquid with a density of this. So now we're looking for the volume. The question is specifically saying, let's calculate the volume. We're going to use this version of the equation that says volume equals mass over density. All right, so if volume equals mass over density, it tells me that the mass is 65 grams. The density is 5.45 grams per milliliter. All right, so in this case, just to make it clear that we're calculating volume, you have grams over grams, they're gonna cancel each other out, and then you're just gonna be left with milliliters, and milliliters is a unit of volume. So that's great that we're gonna just be left with milliliters. So in this case, once again, how many sig figs in 65?
2,
2,
How many in 5.45?
3,
3,
All right, when we do this in our calculator, 65 divided by
12,
5.45. We need 2 sig figs in our answer.
12.
12.
See that it's gonna be 12. So this is 12 milliliters. All right, let's skip a couple of these. Let's go to number 7. Yeah, let's do number 7. And then we'll go ahead and get started with the lab. So I think you guys are getting it. All right, number 7 says, a carver begins work on the following block of granite that weighs 2,700 grams. What is the density of the granite? So this is a block, 3-dimensional. All right, so we know density. It's asking us for the density. Density equals mass over volume. We know that. We know our mass is 2,700 grams. What's our density, guys, or how do we figure out our density?
You
length
multiply
times
all,
width times height.
yeah, you multiply all the measurements.
Okay, do we see that? To get our volume, we're gonna do our length times our width times our height. So length times width times height, whichever one you wanna call whatever. And so basically, we're gonna say density equals 2,700 grams divided by
1,000.
I'm just gonna write it all down here. V equals 20 centimeters times 5 centimeters times 10 centimeters. We write it all down here. We see that this is centimeters times centimeters times centimeters, which gives us our centimeters cubed. So it's still gonna be grams over centimeters cubed. Now, you guys, let's look at all of this. This is all multiplication and division. Can anyone tell me how many sig figs I should have in my answer?
1.
1.
We see that you need 1 sig fig. Yes?
It's
Mm-hmm.
Okay, so great. So in this case, let's just put it all in the calculator like this. I'm gonna put it in the calculator as one big thing. So 2,700 divided by open parentheses. And you gotta make sure you do your open parentheses and close parentheses in a division problem like this. 20 times 5 times 10, close parentheses. We get 2.7. What is this number rounded to 1 sig fig?
3.
3.
3.
3 grams per centimeter
Centimeter cube.
cube.
why is it 1 sig fig again?
Remember, we're gonna go with the least amount of sig figs. How many sig figs in this number?
2.
2.
How many in this number?
1.
1.
How many in this one?
1.
How many in this one?
1.
So the least amount is 1 sig fig.
Yeah, I understand.
All right. Okay, any questions before we go ahead and get started with the lab? How do you guys feel about density?
I got a quick question about the units. Is density always like grams over centimeters cubed, or like is it always over something?
Yeah, so it's a ratio. Remember, it's the mass to volume ratio. So it's going to be the units for mass divided by the units for volume. So it's always going to be a unit and a fraction.
Okay.
You know, so grams is going to go on top, or sometimes it's going to be kilograms over meters cubed, depending on what unit they're asking you to solve it for. But most of the time, it's going to be grams per milliliter or grams per centimeter cubed.
Okay. And then when it's the other ones and then they cancel out, then it's just the one unit.
Yeah,
Right.
so if you're solving for a volume or mass, volume is going to be either milliliters or centimeters cubed or meters cubed. Mass is going to be some form of gram, whether it's a kilogram, milligram, centigram, you know, some form of a gram is mass.
Okay, cool, thanks.
So just, I want to put a quick star. Just a reminder, 1 milliliter is the same thing as 1 centimeter cubed, guys.
Centimeter cubed. Yeah,
Don't
okay.
get that confused. I know they look different. Remember I said that when we talk about liquids, like in this bottle of water, it's usually measured in milliliters. But if we're talking about measuring the volume of a solid, let's say I want to measure the volume of my cell phone, I'm going to do the length times the width times the height, or something that's like in the shape of a cube, just so that way, that's how you end up getting these centimeters cubed. You know, it's hard to measure a solid in milliliters. The milliliters and liters and gallons and things like that are usually for liquids. You can convert them to meters. Yes?
So the unit of volume is milliliter and centimeter cube.
Yeah, so volume can either be in milliliters or centimeters cubed. So if we go back to, I'm just going to pull it up really quickly. If we go back to the section on volume in our notes, remember we talked about volume yesterday on Monday? These are the different units of volume that you can have. You can have a centimeter cubed, you can have a milliliter, you can have a liter, you can have a quart. These are all volumes. Gallon. Think about like your milk, a gallon of milk, if you have milk in your house, or even a quart or a half gallon, all those things in your refrigerator, that's giving you the volume of that container. Every bottle that you get from the grocery store has the volume on it. And it'll either be in quarts or gallons or milliliters or liters. It'll tell you what the volume is.
All right, thank you.
No problem. All right, so that's why we went over these units, guys. So when we talk about the different type of measurement, so for instance, when we're talking about mass, we're talking about grams and kilograms or pounds or ounces and grams. That's what we're talking about. Okay. All right, any other questions before we keep going?
I have one quick question about the sig figs for number 7.
Yep.
So you said it's 1 because 20 times 5 times 10, 5 is the least, and 10 only has one significant figure.
Well,
So-
all these have 1, so they all just have 1 sig fig.
So you wouldn't take the product of that and do that. I mean, in this case, it's 1,000 anyway, but if it wasn't,
Yes. Yeah, that's
Okay.
one.
That's a good question. So what Kelly is saying is, if I say 20 times, let's say, okay, if I say 20 times 5 times 10, it's going to give me 1,000. In this case, yes, it is just 1.
Yes.
That's why I wrote it out this way so we could see that our answer should have 1 sig fig. But either way, we need whatever units, whatever numbers were given in our problem first. So we calculated this 20 times 5 times 10. So we're looking at these numbers, not what the product of those numbers are.
so if you're given the volume, then you just use whatever you're given. But if you need to calculate the volume, you use the least amount of sig figs in the numbers that you were given.
Exactly. And then we
Okay.
still don't round into the end.
Okay, thank
All
you.
right. Good question, Kelly. All right, guys. Let's pull up the Density lab.